Hello, everyone. My name is Itsuhiro Meikawa from Environmental Functional Equipment Company, Limited. Today, I will discuss the importance of mold cooling water and introduce several proposals for solving the challenges related to mold cooling water that many factories face. Our aim is to provide accurate knowledge about mold cooling water and to discuss solutions to water-related challenges. Today, we will explain potential problems that can occur with mold cooling water using photographs and illustrations, deepening your understanding of mold cooling water and proposing solutions. Thank you for your attention until the end. Two common problems in the water systems of molding machines are 1. Red rust. 2. Scale. These two phenomena look completely different and are often thought to have completely different causes. However, in reality, these two phenomena are deeply related to specific aspects of water quality. This photograph shows the inside of a chiller's water tank. Because the water has not been changed or cleaned for a long time, the cooling water is cloudy with red rust particles. Looking at an image like this, the problem of red rust is immediately apparent. Red rust can be seen in various places within the circulating water system for mold cooling. It is often noticed when the water in the chiller tank or hoses changes color, but by the time it is noticed, the inside of the pipes and mold water tubes are usually already corroded with red rust. The images on the previous page are mainly caused by the reasons illustrated. The occurrence of red rust is mainly caused by the presence of three elements: 1. Water, 2. Oxygen, and 3. Iron. These three elements are perfectly present in the mold cooling water circulation system used in molding. Due to its intended use, mold cooling water is constantly in contact with metal, molds, and equipment. The water that has absorbed the metal ions comes into contact with the oxygen dissolved in the water dot, and there are many places within the mold cooling water circulation loop where the air and water come into contact. Now, let's talk about scale problems. Scale is one of the major problems that occur in piping and mold water lines. It is mainly caused by the precipitation of excess calcium and magnesium, or excess silica, in the water. The precipitation concentrates on molds and heat exchangers, impairing the heat exchange function of the molds and machinery. Here's an image of equipment that has experienced scale problems. Are you experiencing problems like this in your workplace? This illustration illustrates the mechanism of scale formation. Scale formation occurs when ions in water precipitate, become visible, due to water evaporation. Water containing calcium and other ions is continuously supplied as replenishment water for mold cooling. Water evaporates, but ions do not evaporate with it. Therefore, ions such as calcium, magnesium, and silica accumulate in the water. Water containing many minerals such as calcium and magnesium is called hard water. On this page, please remember that hard water is prone to problems such as calcium scale formation. When these ions reach a saturation point, the ions that were previously dissolved and invisible crystallize and precipitate, become visible. The photo on the right shows a car washed on a hot summer day. The water was allowed to evaporate without wiping. A clear white scale remains on the hood. Scale formation works on the same principle. The ions that cause scale are colorless. Because they are colorless, we tend to perceive clear water as clean water. This is a trap where we don't realize the water is bad until problems occur. From here on, we will take a closer look at parts that are hard to notice. In most cases, problems with mold cooling water occur inside the piping and water pipes. 1. I've illustrated what is happening inside the pipes and mold water pipes. Normally, inside the pipes and water pipes, there is a constant flow of water, hot water, due to the discharge pressure of chillers, temperature controllers, etc. Point 2. This water flow causes heat conduction within the mold, repeatedly cooling and warming the mold. This is the mold's heat exchange function. Point 3. Over time, red rust and scale will adhere and accumulate on the walls of these pipes and water pipes. Point 4. This causes the inside of the pipes to narrow, disrupting the water flow and causing stagnation, leading to further buildup of deposits. The accumulated scale and red rust inhibit the transfer of heat. Point 5. Ultimately, over time, the mold's inherent heat exchange function will be impaired. If narrowing or blockage occurs in the mold water channels, this will then affect the molding cycle. In one molding cycle, the mold cooling water primarily handles heating and cooling. If the heating and cooling times extend beyond the originally set times, it leads to production efficiency problems. Since the heating and cooling times are controlled by the molding machine, even if a problem occurs in the mold water channels, the cooling time will not increase automatically. However, it will become necessary to cool the mold for an extra 0.5 seconds, or 1.0 second or so, to produce the molded product. This extension of a fraction of a second in the molding cycle is difficult to perceive and therefore rarely goes unnoticed. In other words, problems are already occurring without you realizing it. On the previous page, I mentioned that the effects of extended cooling time are often difficult to notice. However, calculations reveal a significant loss. In the case of molded product manufacturing with a 30-second cycle, reducing the cooling time by 1.5 seconds results in a 5% time saving. In an 8-hour factory, this translates to an extra 50 cycles of production per day. This means reducing the number of working days by more than 2 weeks per year, thus shortening the time spent on manufacturing. Considering labor costs, electricity costs for operating molding machines and related equipment, and other expenses, even a single molding machine represents a considerable loss. What do you think? Based on this explanation, don't you agree that the quality of mold cooling water is a crucial factor in producing high-quality products and efficiently operating the production line? I have a question for everyone here. Do you all know the water quality of the water you use for mold cooling? As I mentioned earlier, there are guidelines that indicate the hardness of water. These are global standards established by the WHO. While most tap water in Japan is soft water, if you broaden your perspective to the rest of the world, most areas have hard water or worse. Mineral water is fine for people to drink, but it's not good water for machinery and equipment. Do you know the quality of the water you're using? Have you ever had a water quality test done? I visited many sites regarding cooling water problems and asked these questions to everyone. But in most cases, the answer is, I don't know / I've never done it. You're experiencing problems, but the cause is unknown. However, the cause of mold cooling water problems is 100% related to water quality. If you haven't done it yet, please have a water quality test done on the water you're using. When I visit your sites, I also conduct a simple water quality test first. Even a simple test can give you some insight into potential problems and trends. Based on the test results, I investigate the cause of the problem and propose solutions. Sharing water quality information within your company allows for correct and rapid response when problems occur. Please compare your company's water quality test results with the appropriate water quality for mold cooling water shown on the next page. Now, as typical examples of problems with mold cooling water, we mentioned red rust and scale. In the previous explanation, we stated that red rust is more likely to occur with soft water and calcium scale problems are more pronounced with hard water. So, which water quality is better for use as mold cooling water? The Japan Refrigeration and Air Conditioning Industry Association has established standards for water quality when used as cooling water for equipment. The standard for water quality indicating soft or hard water is the total hardness parameter, the area enclosed in the red box, is the total hardness. And when used as circulating water for chillers and temperature controllers, the guideline for total hardness is medium hard water with a value of 70. The area enclosed in the red box is relevant, and when circulating water in chillers and mold temperature controllers, A total hardness of 70 or less is considered desirable. However, there is a catch here. As mentioned earlier, using hard water for mold circulating water leads to significant calcium scale formation, causing narrowing and blockage of mold water pipes and machine equipment failure. To make water suitable for mold cooling, it's necessary to reduce impurities such as calcium. In Japan, the average hardness of tap water is below 50, so few factories experience calcium scale problems. More factories suffer from rust. However, looking at water sources worldwide, most regions use hard water. Hard water is unsuitable for machine equipment, especially for cooling molds in molding. The solution to this problem is water softeners and pure water systems. Many molding factories use water softeners and pure water systems. However, are you aware that using these water softeners can accelerate the progression of rust? It's generally known that water softeners and water purifiers remove calcium ions, magnesium ions, and other substances from water, thereby lowering water hardness. However, lowering the total hardness too much can accelerate the formation of rust. This explains why rust is more likely to occur in softened or pure water with low total hardness. The diagram illustrates the inside of a mold's water pipe or piping. Normally, water contains various ions in addition to calcium. Water softeners and water purifiers remove these, reducing the total hardness to near zero, creating a state with few ions in the water. Due to its properties, water with fewer ions begins to absorb ions from the metal it's in contact with. This means that there is a temporary increase in iron ions in the water, and this ionization is accelerated upon contact with the atmosphere. Iron oxide is rapidly generated. Iron oxide then transforms into iron hydroxide and other substances, which float in the water. This results in rust-colored water. Water whose hardness has become too low needs to be raised to an appropriate level, around 70. So how to deal with these problems? Introducing a product called SAVVY-LAINE, a red rust inhibitor. SAVVY-LAINE is a rust inhibitor specifically for molding cooling water that utilizes ionization tendency. The main material is fiber, and the components contained therein become ions and are released into the water. Since all of the ionic components are naturally derived, the product can be directly drained after use, in accordance with Japanese standards. The mechanism for preventing rust utilizes a natural law known as ionization tendency. Potassium, calcium, and other ingredients are released from SAVVY-LAINE tablets in an ionized form. Mold cooling water contains a lot of iron ions because it comes into contact with the mold. When these iron ions ionize, they turn into iron oxide, but this ionization process occurs in order. As more substances in the water ionize before iron does, the speed at which iron ionizes, that is, rust, slows down. The ions released by SAVVY-LAINE are more likely to ionize than iron. Therefore, the logic behind using SAVVY-LAINE is that you can extend the time period over which you can use clean water. When these ions come out of SAVVY-LAINE, the total hardness value, which is measured in water quality tests, gradually increases. There is also a moderate increase in electrical conductivity. The total hardness eventually reaches a level that inhibits red rust and minimizes scale deposition. As a result, the water becomes less susceptible to rust and scale deposition. These are test images of SAVVY-LAINE. S45C iron pieces were placed in both tanks. With SAVVY-LAINE on the left and without on the right. This is a picture from the start. 3 months have passed, and the right side is badly rusted. 6 months have passed. You can see that there is a lot of rust in the tank on the right dot, but although you can see rust on the iron pieces on the left, the water is still very clear. Normally, this would be the time to clean and change the water. We've removed the iron pieces after 180 days. The piece with rust has recovered to the point where it looks like it was made on a lathe, but the piece without rust has a rough surface, and the red rust is so firmly attached to the surface that it won't crumble, even when scratched with a fingernail. 500 days have passed. There is still not much rust in the tank on the left. What about the one on the right? The color of the water suggests that plumbing problems could occur at any time. Normally, the tablet will be replaced after 500 days. SAVVY-LAINE selects a model based on the total amount of mold cooling water it holds. The amount of water held by a chiller varies depending on factors such as output and the distance to the molding machine, so we have detailed model settings. First, add the chiller tank capacity plus the amount of water held by the piping, mold, and molding machine, and then select the model with the next highest setting, then the total amount. The case is stainless steel and the tablet inside is replaceable. The effectiveness will decrease after 1.5 to 2 years, so you will need to replace the tablet inside. All models currently on sale are for chillers, but models for temperature controllers and large equipment are also under development. I tried to illustrate how to use it. Please clean the circulating water system for mold cooling and replace the water. In many cases, rinsing is required several times, but please add the water once it is clean. After adding water, the next cleaning can be done 6 months later. But if the water becomes cloudy due to rust transfer or residual rust from the mold, change the water and check the condition before 6 months. With SAVVY-LAINE, only naturally occurring components are released as ions, so when disposing of the used water, it's perfectly fine to discharge it directly into rivers. When using water softeners or pure water systems, we recommend using SAVVY-LAINE in conjunction as the most environmentally friendly rust inhibitor to combat red rust. Neither releases harmful substances, creating environmentally friendly, trouble-free mold-cooling water. This customer used well water and had been troubled by rust for many years. But using SAVVY-LAINE improved the situation and has already had one update for over 3 years. These are the features of SAVVY-LAINE. Point 1. The rust-preventing mechanism is naturally derived, making it environmentally friendly. Point 2. Cooling water can be directly drained after use. Point 3. Easy to use, add to tank and clean regularly. Point 4. Long-lasting effects 1.5 to 2 years. Asterisk continuous use possible by replacing tablets. Point 5. Compatible with water purified by water softeners and purifiers. How was it? By analyzing the cause, comparing it with water quality, and taking appropriate measures, the probability of mold cooling water problems occurring will be far lower than it is now. If you are still experiencing problems with the water supply for mold cooling water at your site, please contact us. Details of the problem, please attach photos, etc. Details of the equipment, cooling water circulation route, and equipment layout diagram. Water quality test results. If you can provide us with just this information, we will propose a solution to the problems your company is currently facing. We can also provide SAVVY-LAINE through Matsui branches around the world. Please send an email in English to the address below. Environmental Functional Equipment Company, Limited. Atsuhiro Maekawa. Email a-maekawa@kankyo-kinu.com. Thank you very much for listening. There are other causes of mold cooling water problems than those introduced above, but let's work together to solve the water-related problems in your factory. First, please consult Matsui. I will do my best to help however I can. Thank you for your time.